let us discuss this very interesting theorem. So we know that supremum of set S, we have in previous video, we have already seen its definition. So now we have to prove that if the supremum exists, it is unique. Okay, unique, that means only one supremum is there. Let us prove this thing. You know our technique. When we have to prove it is unique, normally we assume that there are two such supremums. Okay, so here let us consider, let it possible S has two supremums, okay, say M1 and M2. So we have to prove that supremum is unique, but I am assuming it has two supremums, okay, M1 and M2. M1 is also supremum of S and M2 is also supremum of S, okay. So let us consider the thing which we have. We have M1 is equal to supremum of S, okay, or we can also call it as least upper bound, okay. You remember its definition that M1 should satisfy two conditions, then we declare it as a supremum or least upper bound. So out of that, first condition is upper bound. See, M1 is a supremum, that means 100% it is upper bound of S. So M1 is an upper bound of S, okay, it is upper bound of S. See, as well as we have M2 is also supremum of S, but M2 is supremum that is, so it has one more name, supremum, that is least upper bound, okay. So M2 is supremum that is least upper bound of S, right? See what we have now, M1 is upper bound and M2 is least upper bound, getting least, smallest upper bound. So therefore, obviously M2 is less than or equal to M1. Since M1 is upper bound and M2 is least upper bound, smallest upper bound, so that's why M2 is less than or equal to M1. As well, now we have a second information also. I started with M1 is supremum of S. Now I will start with M2 is supremum of S. We have M2 is equal to supremum of S. Supremum, that means it satisfies two conditions. So out of that, first condition is it is upper bound. So therefore we can write it is supremum of S, that means M2 is an upper bound of S, getting? But we have M1 is supremum, right? M1 is supremum, that is, it has one more name. Supremum means least upper bound, getting? So that is least upper bound of S, upper bound of S. So now you can easily tell me, okay, M2 is upper bound, but M1 is least, that means smallest upper bound. So that's why obviously M1 is less than or equal to M2. This is 2. So here 1 says M2 is less than or equal to M1. 2 says M1 is less than or equal to M2. So from 1 and 2, what we get? M1 is equal to M2, right? Make a screenshot of it, then we will go further. So we started by assuming S has two supremums, M1 and M2, and finally what we got M1 is equal to M2. That means both supremums are same. So that means given set S has unique supremum. It has only one supremum. Thank you. Bye bye.